Well, I think that question generation is is one of the most important parts of human reasoning, as well as machine reasoning, because when we think, we are talking to ourselves. We are thinking with ourselves, and uh, so so we generate some questions. We answer our own questions. So it's a self-talk. So it's very important for reasoning. But the problem is that we don't have enough labeled data, and supervised learning by labeled data is very expensive. So that's why we want to create some sub questions and consider those sub questions as latent variables, like in the autoencoder framework. So when we say latent reasoning, I mean some sub questions that are hidden, and we want to investigate them, so that finding these latent variables, after finding them, they become very good features for question generation. So in fact, I want to explain this beautiful article, which is latent reasoning for low resource question generation, because in low resource languages, when there is scarcity in labeled data, such as Persian language, Dutch language, Deutsch language, and other languages, we need to find a way to do this. And there are very good articles about question generation. And also, critical thinking is very important if you want to use thinking and reasoning for artificial intelligence and machines. So we need to learn about it in this direction as well. So labeled data is expensive, and your child does not need tons of data to learn. And multi-hop question generation requires complex reasoning and coherent language realization. Learning a generation model for the problem requires extensive multi-hop question answering data, which are limited due to manual collection effort. So the idea is that we treat the unobserved sub-questions as latent variables and propose an objective that estimates the true sub-questions via variational inference. We further generalize the generative modeling to single hop question answering. And so in this article, we use both single hop question answering and multi-hop question answering. We hypothesize that each single hop question is a sub-question of unobserved multi-hop question. So that's why it's important. And propose an objective that generates single hop questions by decomposing the multi-hop questions. So we break these multi-hop questions to some single hop questions. For example, S1, S2, and other sub-questions. So, for example, for multi-hop question reasoning, the supporting evidence is this, and we have some reasoning. But we have some sub-questions that, for example, S1 and S2, and these are latent variables in this paper. So the idea is using autoencoding variational base. I mean, the key idea is that each question, either multi-hop or single hop, can be considered a partially observed pair. So it's a multi-hop question and sub-question, and treat the unobserved part as a latent variable. In the generative modeling of multi-hop question generation, we use the two-phase model as a generation model and introduce a posterior model to estimate unobserved sub-question. The generation and posterior models are jointly optimized via variational inference. For generative single-hop question generation, we instead use a two-phase model as a posterior model to estimate unobserved multi-hop questions. So this is the terminology and problem formulation. that we have a set of n multi-hop question answer and evidence triple. So this is question, this is answer, and C is the evidence. So there are potential relevant sentences like D1, D2, and DK. So these are hidden variables S1 and S2. We want to generate this question. If we don't use planning, this is the left one, which uses generative single hop. But if we use planning variable that I will explain, that planning variable Z, then it becomes the right one. So the probability of your question given your answer and your evidences can be decomposed as this. So we have two data sets, single hop and multi-hop, and we use generative modeling for multi-hop. Because this likelihood is intractable, we optimize its evidence by the elbow. Elbow, I've explained elbow several times. It's evidence lower bound. So instead we maximize this evidence lower bound. And here is the KL divergence between the two distributions. So we can rewrite the elbow with this factorization. So we instead use the elbow, so it's a proxy because it's very simple. So we extend the proposed generative modeling by assuming that each single hop question is obtained by decomposing an unobserved multi-hop question. So the generation model P theta prime and the prior model P phi primes are parameterized respectively, and we treat the unobserved Q as a latent variable and derive the evidence lower bound. And finally, we observe that the posterior in single hop is the same as generative process in multi-hop question generation. So we realize the generation model P of theta prime and the prior are like this. And we can also use the planning variable Z. So the latent planning variable aims to capture the high reasoning level required to answer the multi-hop questions. So we can consider the planning guided mechanism in the generative modeling of single hop question generation. So here P probability of S given your planning variable is modeled by letting the prior and the posterior be additionally conditioned on Z. So we condition on these planning variable as well. And for learning, as I said, we use single hop questions and also multi-hop questions. And we use the elbow for them, and the elbow of question in latent variable, the elbow of those S and your planning variable. So these are decoupled, and these are the experiments for hotpot 30K. So these are very good data sets, and these are measures that we use when using question generation to see if our model is better than state of the art or not.